Keep revising the concepts of the second chapter. Go through all the concepts. Okay. When we solve problems, we'll be able to understand. If you're going to solve problems, then those are online. Are you able to hear me?
Yes, sir.
Okay. So keep revising the concepts. இது எங்க பாருப்பா இங்க
அந்த ஃபைல்ல இருந்து ஒர்க் பண்ணதுனால சேவ் ஆகல.
உள்ள போயிடுச்சா?
நீங்க சொன்னீங்க ரொம்ப ரவிசா பண்ண சொல்லி.
ஆமா. சரி, பட் அதுல ஃபைலே இல்லையே. எதுல எங்க இருக்கு ஃபைல்? அது வெளில போட்டு வச்சிருக்கியா? எங்க இருக்கு? ம். ஓகே. ஓகே. ம். Yes. So we'll get started. So we'll discuss the previous year questions of this chapter, that is the electrostatic potential and capacitance, right? So look at this question. The first one says, a 500 microcoulomb charge is at the center of a square of side 10 centimeter. Find the work done in moving a charge of 10 microcoulomb between two diagonally opposite points of a square. So read this question and try to solve. So what is present? You have a square of side. Those who are online are able to see and listen.
Yes, sir.
So there is a square, guys, don't talk. There is a square of side 10 centimeter. There is a 500 microcoulomb charge which is placed at the center of it. Now what you need to do is, due to that 500 microcoulomb which is placed at the center, there would have been potential developed at all the corners of the square, right? So if I take the corners of the square as ABCD, there would have been potential developed across all the corners. Am I right? Now, what is the amount of work that we need to do to move a 10 microcoulomb charge, right, between two diagonally opposite points of a square? So I need to move the charge of 10 microcoulomb from A to C. So what is going to be the amount of work done? So work done to move the charge between A to C is equal to the charge itself multiplied with the sorry, what is that called as? So it is a potential difference between the points AC. So when this 500 microcoulomb is placed at the center, what would have been the potential at point A and point B? Sorry, point C. What would have been the potential that is developed at point A and point C? So due to a point charge, what is the potential developed at A and C? VA is equal to, it is K, let me call it as Q1 divided by R, where Q1 is 500 microcoulomb, R is this distance, right? So what about VB? That will be KQ2 divided by the same R. So what is that? Sorry, VC. So what is that you are able to conclude from this? They both are at same potential. So when they are same potential, then what is going to be the potential difference? So if this is 0, then what is going to be the answer? So here you need not calculate anything. Okay, it's a very short answer question. The only thing that you need to observe is, due to the source charge, what is the potential at both the points? And if there is a test charge which is moved from one point to another at those 2 points where the potentials are known, what is going to be the work? So how are you supposed to present it in the exam? Due to the 500 microcoulomb charge, the potential developed at point A and point C will be the same. Hence, the potential difference between the points will be 0. After that, you write this step. WAC is equal to Q into VAC, and you write it as 0. Yeah. Shall I proceed? So the next one. A point charge Q is placed at point O, right, as shown in the figure. Is the potential difference VA minus VB positive, negative, or 0 if Q is positive and Q is negative? So what would be the difference between the potentials at point A and point B had the charge Q been positive? So what will VA minus VB be, greater than 0 or less than 0? Right. So when Q is positive, when the charge is positive, what does it indicate? Due to the positive charge, the electric field is going to be away from it. And what is the relation known between electric field and potential? So what does this minus sign indicate? So use that logic and tell me. So had Q been positive, what would have been the direction of electric field? This is the direction of electric field when the value of Q is positive, right? So obviously, which one is greater than the other? VA is greater than, so VA minus VB would have been. So when Q is negative, what would have happened? This would have been the direction of electric field when it is negative. So what will happen here? Will be less than 0. Okay. So make a note of this. You don't write the question, just write down the answer. I'll share this PPT after the class. Done? So the next one. Why is the electrostatic potential constant throughout the volume of a conductor and has the same value as inside, which is present on its surface? What is this actually? You have seen this. This is the electrostatics of conductor, the fourth point in it. So what are the electrostatics of conductors? What are the points in it? What is the first point? The net electric field inside a conductor is 0. Second, electric field is always perpendicular to the surface of the conductor. Third, any excess charge given will go and sit only on the surface of the conductor. Fourth, this one. So this is the fourth one. Electrostatic potential is constant throughout the conductor and it is going to have the same value as that present on the surface of the conductor. Okay. Then what about the fifth point? Electric field at the surface is sigma divided by epsilon naught times n cap. N cap represents the unit normal vector, right? And what is the last point? Electrostatic shielding. So these points are to be remembered. Okay, they are very, very important. So having said that, why is electrostatic potential constant throughout the volume of the conductor? So what can you say? What is the mathematical logic you are going to use? E is equal to minus dV divided by dr. So what is the electric field inside a conductor? So electric field inside is going to be 0. So derivative of which function will be 0? This implies dV by dr is a 0. That clearly indicates that V is a constant. So this is a mathematical proof you need to give to this statement. Okay. Similarly, if you have another question, I've already given you the proofs. So next time, go through them. Is it clear? Shall I proceed? No, but the potential is the same as the value that is present inside. E is not 0, but potential is kq divided by r. Potential will take this value. What they're trying to tell us is this is going to be the value on the surface as well as inside the conductor. That is the main. See, there is a concept called as Van de Graaff generator, which you can see in your textbook. For that, you have this concept of what is the potential inside the shell. But that concept is deleted. That is why I didn't teach. So if at all your preparing for any competitive exam, right? What will happen is, see, this kind of a question I've seen from your school also being asked many times, though this is deleted. What they will do is, they'll give you what are the charge present on the surface. See, suppose the charge present on the surface is Q, okay? And let's say the radius of this particular spherical shell is going to be R. Then what is going to be the potential inside? Answer will be KQ divided by R. Okay. See, suppose what they will do is they'll take the concentric shells. If I take this to be R1, so what is going to be, if I take this to be Q1, what is going to be the potential due to that surface inside? It will be, for here, this one, it will be KQ1 divided by R1. Sometimes they'll ask you the difference in potential also. So all that you need to know is write this equation, subtract both. Okay, but I repeat, this is not a part of syllabus for CBSE. Okay. So is this point clear? So this is the meaning of the statement. Electrostatic potential is constant throughout the volume of the conductor and has the same value as whom? As the value that is present inside. So on the surface and inside, it has the same value. Okay. So this is the one which is given. Next. I'll give you 2 minutes time. Derive this and show it to me. So this is a derivation. Derive the expression for the electric potential at a point along the axial line of an electric dipole. Derive this. Those are online, switch on your videos. Netra, Prakash, and Divya, please switch on your videos. Yeah. So once you complete it, no, those are online. Show it to the screen so that I want to check. Divya and Prakash, I asked you to switch on the video. So what will be the answer? Did you get it? At least check your notes, go through it once and try to do it. No, don't directly copy it. Go through it once, try to do on your own. This is not potential, there's electric field. Give me a pen. One positive charge, one is negative. When you did VA plus VB, one should be minus, no? Either minus, either plus, sir. If this is plus, you're calculating at this point, no? So for positive, it is R plus diagram either 2A. This is R, sorry, this is R. This distance is R plus A. This arrow mark should come till here. And this is R minus A. Puridam. R is from the center, this is correct. இங்கே வந்து R plus A இல்ல? This is A, this is R. So it is going to be how much? Anybody with the answer? Kp by R square. Provided you have taken the point closer to the positive charge. If you have taken it closer to the negative charge, you will get minus Kp by R square. So this is the diagram, no? So this distance is R, this is A, and this is A. So how much will this distance be? It will be R plus A. And how much will this distance be? It will be R minus A. So if I take this to be A and B, what is the potential due to the charge at A? It is KQ divided by R plus A. What is the potential due to the charge at B? It will be minus KQ divided by R minus A. So add both, you will have KQ common 1 by R plus A minus 1 divided by R minus A. So what are you going to get? KQ into R minus A minus R minus A, the whole divided by R square minus A square. R and R will get cancelled. So minus 2A into K into Q. Sorry, minus 2A into Q is minus P. So it will be minus Kp divided by R square minus A square is approximated to R square. So minus Kp divided by R square will be the answer if this is how the diagram is taken. Right? So they have taken the positive charge closer to the point and the negative charge away. Okay. Next. This is also an important one. Derive an expression for the potential energy of an electric dipole of dipole moment. It's not movement, it is moment. Dipole moment P vector in the electric field E vector. So you will have uniform electric field like this, in which there is a dipole placed. So this will be Q and this will be Q, right? So this is the direction of electric field. Now you need to take the torque into consideration, then the work done into consideration, derive the electrostatic potential energy. What will be the final expression? Yesterday also I told you. When I explained the concept of equilibrium, I asked you to go through this. It is minus PE cos theta, right? So how to derive this? Check your notes. Check your notes, go through it once, then write it. to derive an expression for the potential energy of an electric dipole of dipole moment. So what is the first step? What is the first step? So first you will write the expression for work done. So how will you write it? So dW is equal to tau into d theta, right? The next step will be about integrating it. So what is the value of torque? P sin theta times d theta is what is dW. So when you integrate it, W will be equal to PE into integral of sin theta is minus cos theta. From where to where? Theta 1 to theta 2. Substitute the upper limit and lower limit. So answer will be minus PE into cos theta 2 minus cos theta 1. So initially, if the system was perpendicular to the electric field, then cos theta 1 would have been 0. So answer would have been minus PE cos theta. Right. I hope you are able to recollect this. Yes. So this is how you need to write. Like you take this diagram, you need to write all these things. Consider a dipole with the charges. So whatever story I told you, right, that has to come in words. Right. So this one, and the final answer will be minus PE into cos theta 2 minus cos theta 1. Okay. So 22nd. Yes. There are 2 point charges, 4Q and Q, which are separated by 1 meter in air. It is 1. Okay, they are separated by 1 meter in air. At what point on the line joining the charges is the electric field intensity 0? There's something which we did yesterday. But the only difference is 4Q and Q, there the distance was 2 meter. Here it is 1 meter. Okay, first part, I want you guys to do it. Second is also calculate the electrostatic potential energy of the system of charges, taking the value of charge Q is equal to 2 into 10 power minus 7. They're asking calculate the electrostatic potential energy of the system. What is the electrostatic potential energy formula? It is K Q1 Q2. I'm talking only in terms of magnitude. K Q1 Q2 divided by the distance of separation between them. So I'm giving you exactly 5 minutes time. Do both the questions fast and show it to me. So yesterday's one, it's simple. You can do it fast. Draw the diagram, do it fast. So for the first one, what is the expected answer? Will it be greater than 1, less than 1? It should be less than 1. Anybody with the answer? 2 by 3. When I don't know this. Yeah. 2 by 3 from where? Both are positive. From which charge? So you need to report the 2 by 3 from the charge 4q. So what is the answer? 2 by 3. Did everyone get it? So the answer for the first one is 2 by 3 meter from 4q charge. Right? So also calculate the electrostatic potential energy of system of charges taking the value of charge q is equal to 2 into 10 power minus 7. So for this one, what is the answer? It is 9 into 10 power 9. What is the value of q1 into q2? So q1 into q2 is 8q square. Sorry, 4q square. So it is going to be 4 into, what is the value of q square? 4 into 10 power minus 14, the whole divided by r. What is the distance of separation between them? It is 1. So 16 into 9, 144. So it is going to be 144 into 10 power minus 5 joule or 1.44 millijoule. So 144 into 10 power minus 5 joule or 1.44 millijoule. This is going to be the value of electrostatic potential energy. Am I clear with this? Shall I proceed? Yeah. So look at this one. There are 2 point charges 20 into 10 power minus 6 coulomb and minus 4 into 10 power minus 6 coulomb, which are separated by distance of 50 centimeter in air. Find the point on the line joining the charges where the electrostatic potential is 0. In this case, is there a possibility of the potential to become 0? Look at the question. No? So there is a charge of 20 into 10 power minus 6 coulomb and minus 4 into 10 power minus 6 coulomb, and they are separated by distance of 50 centimeter in air. So find the point on the line joining the charges where the electric potential is 0. Is it possible? Why? Because you have a system of unlike charges. So where will you get the potential to be 0? Closer to the point with lesser magnitude. So closer to the point with lesser magnitude. So first part, you can do it. Also find the electrostatic potential energy of the system. For second one, again, the concept is simple. It is K Q1 Q2 divided by R. Okay. So do You have, I think I've solved this problem. This is not your notes. Okay. But, okay. This you're preparing from the videos. You didn't attend even one class? First class I did this. It's very simple. You need to write the potential due to the first charge at a point, potential due to the second charge at a point. Sum of both should be 0. KQ by R. VA. You need to write VA and VB at a point. Sum of both should be 0. So what will happen is whenever you're writing potential due to positive charge, you need to put the positive sign. Due to the negative charge, you need to put the minus sign. Okay, try it out. The problem. முன்னாடிக்கே இன்னும் answer வரல உனக்கு. You did a mistake. You should equate them. Why did you add them? It will change the whole concept. These electric, but the electric field vectors are in opposite direction. No, you're doing the vector sum. That will change the whole meaning of the problem. Another one answer வரல. So you should equate them. But in the problem, you should add them. Add பண்ணும்போது என்ன ஆகும்னா, due to the positive charge, you will have positive potential. Due to the negative charge, you will have negative potential. So positive value plus negative value will be equal to 0. And the negative அந்த பக்கம் போயிடும். So this kind of problems I did it in the first class. ஒரு வாட்டி போய் இன்னும் check பண்ணுறோம். இந்த கல்பகேஷ் என்ன அது? இங்கே போடும்போது ஈக்குவல் டு போட்டதுக்கு அப்புறம் இது வராது. எங்க எழுதுன நோட்ஸ் எங்க இருக்கு? இது பிசிக்ஸ் தானே இது? ஃபர்ஸ்ட் நான் சொல்லி கொடுத்துருப்பேன் போ. கான்செப்ட்ஸ் மட்டும்தான் இருக்கு. நான் சொல்லி ஒரு ப்ராப்ளம் பண்ணனடா. எந்த ப்ராப்ளம்? Did I do a problem based on this concept previously? Example, and I asked you, I told you exercise the first problem is same concept. Check your notes once. Oh. Did I solve or not? Did I solve a problem based on this or not? Yes or no? Yes or no? First, உங்களுக்குள்ள ஒரு யூனிட்டி வரும். What is it? Did I do or not? Please tell me. No. That's what I did. No. So it's a similar problem. I think that is when I told you, right? I took 3 cases and told next time don't waste time on 3 cases. 2 case மட்டும் பண்ணோம். Where will you take the point to be? That also I would have mentioned. It should be closer to the point where the charge has lesser magnitude, right? It's a similar problem. Do that. Those are online. Are you solving it?
Yes, sir.
Did anyone get the answer as 250 by 6 or 50 by 6? 250 by 6 you got, okay. You will get two options, either 250 by 6 or you will get 300 minus this, you will get 50 by 6. These are the two options that are possible. So if you get 250 by 6, from where will you get? It is from which charge? From this 20 into 10 power minus 6. You will get 50 by 6 from the negative charge. Okay. Next. See, this is one of the points. What will be the other point? So you will have 20 divided by 50 plus R is equal to 4 divided by R. So you will get R is equal to 50 by 4 or 25 by 2 also. So basically the meaning of this problem is, see, you have a 20 microcoulomb charge here and negative of 4 microcoulomb charge here. So this is 4, this is 20. So the point that you're going to consider will be on either side of this 4 microcoulomb charge. Am I clear? So if you take the distance from here to be R, then how much will this distance be? 50 minus R. I'm not doing any conversions. So all that you need to do is you need to calculate the potential due to the 20 microcoulomb at point P, which will come out to be K into 20 divided by R should be equal to K into 4. Don't write minus 4. You will write minus 4 when you write both the potentials on the same side. Because I've already taken it to the other side. Because what does the question say? The sum of the electric potential is 0. Means this potential has got added to this value and the value has come out to be 0. So the negative has gone to the other side as positive, divided by 50 minus R. K and K are gone. This will go 5 times. So when you cross multiply and solve, you will get 250 by 6. So 250 by 6 is the distance from the positive charge, or you can also get 50 by 6 from the negative charge. Both are right. But after you report the answer, you need to mention from which charge you're calculating, because the question is about distance. Okay. Secondly, where will you take the other point to be? This is positive charge, this is negative charge. So if I take the point P dash here, and if I take this distance to be R, then how much will this distance be? It will be R plus 50. When you take this concept and solve, what will you get? You will get, this is 20 and this is 4. So due to the 20 microcoulomb charge, what is going to be the potential at point P dash? K into 20 divided by 50 plus R, or R plus 50, should be equal to K into 4 divided by R. That's what I wrote. When you solve for it, you will get 25 by 2. So 25 by 2 is the distance from 4. From the 4 microcoulomb charge. Are you able to understand? So you can expect these kind of problems. All that I'm discussing are previous year questions only. Okay, so you can expect them. What about the electrostatic potential energy of the system? That is very simple. So it is 9 into 10 power 9 into Q1 into Q2. It is going to be 80 into 10 power minus 12 divided by 50 into 10 power minus 2. Right, 0 and 0 are gone. So 10 power minus 2, this will go as 10 power minus 10. So you'll have 9 into 10 power 9 into 8 into 10 power minus 10. This will come as 10 power minus 1 divided by, so everything will go off. 10 power minus 1 divided by 5. So you'll get 72 divided by 5 into 10 power minus 1. 72 by 5 is how much? 14.4. So 14.4 into 10 power minus, or 1.44. 1.44 joule is the answer. I'm not concerned about the sign here. So 1.45, and the other one is, how did they get 5 by 15? Sorry, 5 by 14. It's meter and they've simplified it. But where did they take? And see, in the solution, there is one point that is missed. What is it? They've reported only 1 point. But for these kind of problems, you'll have 2 points. One between the charges and one on the side of the charge with a lesser magnitude. So you need to write both the points. So make a note of this. If you have forgotten, at least next time, make sure that you solve this kind of a problem. You can expect one of this. Shall I proceed? Solve this. Calculate the work done to dissociate the system of 3 charges placed at the vertices of a triangle as shown. So the amount of work that we need to dissociate the charge is actually the amount of potential energy the system possesses. So indirectly, whenever you have this kind of a question, right, they're asking you, what is the potential energy of the system? So how many charges are there in the system? 3 charges, no. So how many terms will you get in the expression for potential energy? So U is equal to, so if I take this as 1, 2, 3, you get U is equal to U12 plus U23 plus U31. Right, basically it is 3C2. So the number of charges that are there, the combination of those charges as a base of 2. So why 2 is because you take 2 charges at a time. I think this I've given it to you. Did I give? Okay. See, why I gave that is, suppose there are 4 charges in the system. Then you need to be clear. How many terms will you get? You will not get 4. You will get 4C2 terms, which will be 6. Because what mistake we'll do is, let me concentrate on this point. See, there are 4 charges. No, if I take this to be 1, 2, 3, 4, you write U12, 2, 3, 3, 4, 4, 1. So those are the charges at the corners. But what about the diagonals? You need to write U13 and U24 also. So you'll get 6 actually. So that is basically 4C2. Suppose they give you a problem based on pentagon. Will 5C2. So everybody knows what is 4C2 is 4 factorial divided by 2 factorial into 2 factorial. Okay. So 4 into 3 into 2 divided by 4. This and this are 1. 6 is the answer. So using that logic, what will be the answer here? So U12 is K. Directly tell me, no? Tell me with the sign because I have combination of charges. So tell me with the sign Q into 2Q. It is going to be 2Q square. Is it an equilateral triangle? 10, 10, 10. So it is going to be 10. Okay. Or I'll write it as A for now. In the end, I'll substitute the values. So 2K K into 2Q square divided by A plus what is U23? K into, that's right, minus 8Q square divided by A. So what about this one? K into minus 4Q square divided by. So this is how it works. So you can add everything. Since the LCM is A, just add the values, you'll see. Minus 12 plus 2. So basically you will get 10KQ square divided by A. So 10Q square divided by A. A is going to be 10. Substitute it, you'll be able to solve it easily. So this is a simple problem. Did they give the value of Q? No. 1 minute. Value of Q is not given. You can just use this logic. Is this point clear? Clear with this? No? Shall I proceed? Okay. I think they have not given us a value. Here in the solution, they have put Q as 1.6 into 10 power minus 60, but for us, the value is not given, so we need not worry about it. This one. Calculate the amount of work done to dissociate a system of three charges 1, 1 and minus 4, which are placed at the vertices of an equilateral triangle. This you can solve it fast now. Calculate the amount of work done to dissociate a system of three charges 1 microcoulomb, 1 microcoulomb and minus 4 microcoulomb placed at the vertices of an equilateral triangle of side 10 centimeters. So what is the answer? So what is the answer? Minus 63 into 10 power minus 2 joule. Did you understand? So this is going to be the final answer. Okay. So this is how the diagram looks. This is a mathematical expression. This is the final answer. So 0.63 joules of energy is required to dissociate this kind of a system. Okay. So that's all for today. The next class will solve some problems based on capacitors. So those are online, we can wind up.
Thank you.
Yeah.
Thank you, sir.